And this is the Java implementation of a dots and boxes problem. For this implementation, I have 4 classes. The main class actually serves as a main input class for game parameters. So when I run the program, it asks for size of a board for the current strategy and also for maximum tree depth. So it also shows the indexes for rows and columns of the board. So I can enter the column coordinate and row coordinate and where to place the line. Next, it will show where it placed the line for me and also where the AI placed the line. So the main implementation actually for this game exists in the state object, and state is basically represents the state of the board, where it has player score parameter, AI score parameter, and is it a human or AI turn parameter. The board represents as a two-dimensional array of a box object, and the box object is basically tells me where the lines exist in this object. So it is a hash map of position and boolean, and position as an enum. Basically, for all of the position, it just tells me false or true. So for top it will be false or true, for bottom will be false or true. So the main, also there is a possible moves parameter where it will basically store all of the possible moves for that box. The main method is the placeline method, where basically it will check if the move that user tries to make is legal move, and also if it is a legal move, then it will check. It will find this box in a board. It will find this box on the board and also check if there is a neighbor box exists for the current box. And if the neighbor box exists, then for all of those boxes, it will check for current and for neighbor. It will check if it placed the line, and it will be closed box. It means all of the lines will be set, and then it needs to set the player and also increment the score for that player accordingly. And then we'll just change the turn to the human or to the player, to the AI. The strategies object actually has all of the implementation for Minimax and Alpha Beta implementations. So Minimax method has basically the recursive implementation of the Minimax algorithm, where depends on the of the turn, it will go to the maximum or minimum implementation. So that means for all of the moves, it goes and goes to the recursive step, and also after the recursive step, it go to percolation. And in the percolation, it basically check for if it is a maximum player, which means it's an AI player. It will check the current score, and if the current score is more than this percolation step score, then it will check this step score to the current score, and basically set the best move to this move. The opposite happens to the minimum player, which is a human player, where it will set the minimum score, always try to find the minimum score and set the best possible move for that. And also the heuristics is the difference between the AI score and the player score here. The alpha beta implementation looks similar. However, there is a difference on the percolation step, where it will check for the alpha and beta parameters. Basically, it will check for the alpha, beta, and the current score. So if alpha it will check for check for alpha and betas, and it will decide if it needs to investigate the tree further or not. So that will actually save a lot of space here.